In this section, we're going to talk about the derivative, but we're going to use the shortcut rules for finding derivative. So as a brief reminder, you're still finding the derivative. It still means the slope of the tangent line. It still means the instantaneous rate of change. The rules that we talk about today are what some people call the shortcut rules, and they make taking the derivative a very simple process. The first rule we're going to learn is the power rule, and it says for f of x equal to x to the n power, then the derivative of f prime of x, is equal to n times x to the n minus 1. So in other words, in order to take the derivative of x to a power, you bring the power down to the front and multiply that by x raised to 1 less than the original power. Example number 1. Find the derivative for each function f of x using the power rule. F of x is equal to x to the 6th. So f prime of x is equal to, bring the 6 down, times x, and then lower the power by 1 to create a 5. So it's 6x to the 5th. B, f of x is equal to x to the 19th power. So f prime of x, bring the 19 down, times x, lower the power by 1 to 18. 19 times x to the 18th power. C, f of x is equal to 1 over x to the 4th. Well, we can't do it with the x in the denominator. It has to be written in the numerator. So let's rewrite f of x as x to the negative 4 power. Now we can take the derivative, bring the negative 4 down, times x, lower the power by 1. Negative 4 minus 1 is negative 5. And then because the original function started out with the x's in the denominator with positive exponents, you have to return this answer back to that form. So the negative goes in front. The 4 is not affected by the negative exponent, so it stays on top. And x to the 5th floats down to the bottom, making it x to the positive 5th power. Example D, f of x is equal to 1 over x to the 8th. So that's equal to x to the negative 8. Take the derivative. F prime of x is equal to negative 8 times x to the negative 9. And that's equal to negative 8 over x to the 9th. A couple of things to note about taking the derivatives here. You don't use equal signs between the function itself and it's equal to the derivative. The function and the derivative are completely separate functions, so we would not write that. You just start writing a new equation, and there's no equal sign that connects those. But if you do have a derivative here and that is equal to a new simplified form of the derivative, then you do say that those are equal. Next is the constant multiple property, and it says the following. If f of x is equal to k times g of x, and this k is a constant, that means it's a number, then the derivative, f prime of x, is equal to k times the derivative of this other function, g prime of x. So in other words, if you have a number that is multiplied by a function and you want to take that derivative, you keep that number as a constant multiplier in front, and then you multiply by the derivative of the other part of the function. Let's take a look at example number 2, find the derivative using these two rules. So A is f of x is equal to 3x to the 5th. Now the way to think about this is 3 is the constant multiple, and the other function that you need to take the derivative of is x to the 5th. So that derivative, f prime of x, is equal to the constant multiple, 3, times the derivative of x to the 5th. Bring the 5 down, times x to the 4th. And then you simplify this by multiplying the 3 and the 5 together. You get 15x to the 4th. That's technically the way that you do this. Practically what we do is we say f prime of x is equal to, bring the 5 down, multiply it by the 3 to get 15 times x to the 4th. You just sort of do it all in one motion, one step. Example 2b, f of x is equal to 8x cubed. So f prime of x is equal to, bring the 3 down and multiply, 24x squared. Part C, f of x is equal to negative 9 over x to the 7th. I need to rewrite this one with the x to the negative 7. Now I can take the derivative. So f prime of x is equal to, bring down the negative 7 and multiply. Negative 7 times negative 9 is positive 63. Times x, lower the power by 1, negative 8. And that's equal to 63 over x to the 8th. Let's take a look at the sum and difference properties for finding derivatives. For a function f of x equal to g of x plus h of x, then the derivative is equal to g prime of x plus h prime of x. So in other words, if you have a function that is the sum of two other functions, g and h, then to find the derivative, you just take the derivative of g and the derivative of h and add them together. Same thing for the difference. For f of x equal to g of x minus h of x, then the derivative, f prime of x, is equal to g prime of x minus h prime of x. Now you may be wondering why we're making a big deal out of this and giving it names and showing you all this. Well, it's because it doesn't work for multiplication and division. There are special rules for finding derivatives in those situations. So we will go over those in the next section. But for sums and differences, works out great. Example 3. Find f prime of x for each function f of x. A, f of x is equal to x squared plus 7x plus 8. So we're just going to find the derivative of each of the three parts individually. The derivative of x squared is 2x. The derivative of 7x is just 7, because this is 7x to the first. So to find the derivative, you would bring the 1 down and multiply to get 7 times x to the 0 power, but x to the 0 power is 1. So this is 7 times 1, and it is 7. And then the derivative of 8 is actually 0. Let's see that over here. So suppose you have 8. That's technically 8 times x to the 0 power, because x to the 0 is 1. And if I have to write it with x to a power, that power is 0. So to find the derivative, you would bring the 0 down and multiply. So that's 0 times, and then it doesn't matter because it's 0. And that is one of the other rules that we talk about. The derivative of a number is just 0. And that's your answer, 2x plus 7. Part B, f of x is equal to 3x to the fourth plus 2x cubed minus 9x squared plus 2x minus 8. So we take the derivative. F prime of x is equal to, bring the 4 down, you get 12x cubed plus the derivative of 2x cubed is 6x squared. The derivative of negative 9x squared is negative 18x. The derivative of 2x is 2. And the derivative of negative 8 is 0. Part C, f of x is equal to 4 over x squared minus 3 over x plus 100. Well, we need to rewrite this in the correct form so that we can take a derivative. So we're going to move the x squared to the top as x to the negative 2. And we're going to move the x to the top as x to the negative 1 plus 100. So notice that I didn't take the derivative of any piece yet. You cannot mix the function and the derivatives together. You just leave them separate, and then and you rewrite the function algebraically first, and then you go ahead and take the derivative. So the derivative of this function now is going to be negative 8 times x to the negative 3. Next part, bring the negative 1 down. Becomes positive 3 times x to the negative 2. And then the derivative of 100 is 0. This now is equal to negative 8 over x cubed plus 3 over x squared. Example number 4. Find dy dx when y is equal to the fifth root of x to the seventh minus 1 over x. Dy dx is another notation for derivative. It comes from the original version of slope, delta y over delta x. And you know that the Greek letter delta is our letter for d. And so dy dx stands for the derivative, which is the slope. It's just another notation. And it's actually a useful notation when you start to do other things. So first, we're going to rewrite y as x to the 7/5 power minus x to the negative 1. And then dy dx. Also, there's another thing about how you read this. It's just dy dx. You don't think of it as a fraction when you read it. You don't say dy over dx. It's just the 4 letters. Dy dx. And then that's it. All right, let's take this derivative. So we're going to bring the 7/5 down times x. Subtract 1 from the power. So 7/5 minus 1 is 2/5. Now there's a neat little trick that you can do to subtract 1 from a fraction like this. You just take the numerator minus the denominator, and that number becomes the new numerator. The denominator stays the same. And then we have minus x to the negative 1. We want to take that derivative. Bring the negative 1 down. It multiplies by that negative to give me a plus times x, lower the power by 1 to negative 2. And then again, you need to revert these formats back into the same format as the original. So for the left term, that was a radical notation. So the 5 in the denominator becomes the fifth root, and then the power becomes the power of the x on the inside. It's the fifth root of x squared, and the 7/5 in front. Plus, we're going to move the x to the negative 2 down to 1 over x squared. Example 5. Where does the function f of x equal to x cubed minus 3x squared minus 24x plus 17 have a horizontal tangent? So first, let's analyze what this question is asking for. Well, first, it's asking for information about the tangent line. We know that we get tangent line information from the derivative. And then it's asking where the tangent line is horizontal. Well, that means that the slope has to be equal to 0. So this is asking for where f prime is equal to 0. So that's the meaning of horizontal tangent line. So let's find the derivative of the function. So the function was x cubed minus 3x squared minus 24x plus 17. So we take the derivative, bring the 3 down, 3x squared. Bring the 2 down, minus 6x, and then minus 24. We're going to set this derivative equal to 0 and solve for x. So the first thing I notice is that all three terms are multiples of 3. So we're going to take out a 3. And that leaves me with x squared minus 2x minus 8, still equal to 0. And then I'm going to factor it. So we get x and x. What two numbers multiply to give you 8 and subtract to give you 2? That would be 4 and 2. The 4 needs to be negative and the 2 needs to be positive. Then you set all three parts equal to 0. So 3 equals 0, x plus 2 equals 0, and x minus 4 equals 0. Well, 3 equals 0 doesn't have any x's, so that doesn't yield anything. But these other two do. So we get x is equal to negative 2 and x is equal to 4. And those are the 2 points where this function has a horizontal tangent line. Example number 6. A medical team researching the spread of a virus has determined that after t days, the number of people infected is n of t is equal to 4t cubed plus 9t plus the square root of t for t between 0 and 20. How many people have been infected after 6 days? All right, so how many people? That's asking for the number of people, which is just exactly what the function n gives me. So there's no derivative here. We just apply 6, and that's going to be 4 times 6 cubed plus 9 times 6 plus the square root of 6, and that's equal to 920 people. And then part B, at what rate is the virus spreading after 6 days? Anytime you're asked for a rate, that's a big indication that you need the derivative. So let's take the derivative of n. And so the derivative is going to be, bring down the 3. 3 times 4 is 12. So it's 12t squared. Derivative of 9t is 9. And the derivative of the square root of t. All right, let's do this one out to the side. I'll do it with x. So suppose that's our function. The square root of x is actually x to the 1/2 power, because the denominator represents the root, which is the square root, and the numerator represents the power. So it's x to the first on the inside. The index of a square root is 2, so that's the root. So this is the square root function. Now, to take the derivative, you bring down the 1/2 times x, lower the power by 1. 1/2 minus 1 is negative 1/2. And then you rewrite this. And you rewrite it, so it's going to be 1 over, there's the 2. X goes to the denominator with 1/2, because the 1/2 becomes positive. And then you revert this into the radical form. So the derivative of the square root function is 1 over 2 square roots of x. If I were you, I would memorize this one. This one comes up an awful lot. And so instead of having to go through that every time, you should be able to just sort of, there it is. So we're doing this piece right here. The derivative of the square root of t is going to be 1 over 2 square roots of t. At what rate is the virus spreading after 6 days? So that's the derivative evaluated at 6. So we plug in 6, and we get 441.20. And then what would the units be? Well, n is measured in people per, and then t is measured in days. So it's 441.20 people per day. A couple of notes here on this one. Notice that we needed to use a whole number on the first one because it is talking about people. That has to be a whole number. But on this last one, we can use a decimal because it's a rate of change. And that's fine because that's a ratio. That's no problem. All right. Thanks for watching.